So another thing we can do with alkenes is transform them into cyclopropane. So think about what cyclopropane it looks like. It's essentially just a triangle, right? A three-membered ring where they're all carbons. So one way to do this is to take your alkene, add some CHCl3, some chloroform, and some base, and you'll get a cyclopropane, except you'll still have two Cl's attached here. And so the mechanism here isn't too bad. First, we're going to have some of our base deprotonate our chloroform. And if you can think about that, that makes sense because this chloroform has a lot of inductive effects, allowing it to store or stabilize this negative charge. Chlorine, of course, we know is a good leaving group, so it can just go ahead and leave. And so what we have here is what's known as a carbene. And a carbene is basically a carbon with two bonds and one lone pair, right? So it's totally neutral carbon because it still has, formal charge of 0 here. And so it all looks good there. And then basically it just cyclizes with our alkene. And so you can see where these two chlorines come from. The other option is to add some CH2I2 and then some zinc copper alloy. Right, so the zinc and copper combination is an alloy. We won't look at the mechanism of this reaction, but it forms a cyclopropane. This time without any chlorines or iodines or anything like that on the side.